So you're not being recorded. The only thing that's being recorded is my computer screen, so people can follow along with notes, and it's also recording the sound in the room. So if you ask a question, I'll probably just repeat it, just so the recording can hear what I'm saying. Okay? All right, so the first section we're going to cover in the text is the P sections. So the P sections it's a review. So a lot of what you're about to see is hopefully something you've done before, all right? Which is probably going to make that first exam not too terrible, okay? Because it'll be a lot of review. Now, what I'll do is, did my pen just, there we go. So what I'll do is, let me know if the text I'm writing up on the screen is hard to see, and I'll increase the size of the marker that I'm using. So just let me know. All right, so let's go ahead, and I'm going to leave it like this because this is my backup pen. I forgot my actual pen, and it won't actually do erasing with that bottom thing. So I'll just have to leave it like this. So section P2, and again, feel free to follow along, or if you'd rather just listen and watch, that's cool. So section P2 is on integer exponents, and scientific notation. All right, so that's our topic. So I'm just going to kind of go through some of the integer exponent rules, because this first section is going to end with how to simplify expressions and sort of how I would like to see final answers given when you're simplifying an expression. So here's, I guess we'll call this rule number 1. Okay, if you have, let's say, a is an integer, okay, and n is an exponent, I'm sure you've seen an integer raised to an exponent before. So something that looks like that, a to the n. And we also call the integer in this notation, we call this the base. So a is the base of this exponent n. So what do you do when you have this particular item in an expression? All you're doing is you're going to be multiplying a by itself, however many times is equivalent to your exponent. So this would just be, a times all the way up to one last a, where the sum of all of these multiplications is n. Right? So when you do something like 2 squared, something really simple, right? The exponent is 2, which means I'm going to be multiplying the base 2 times. So it's just basically 2 times 2, and we get 4. Okay? Now there are some special cases. Like this. What if you saw a to the 0 power? Or 0 exponent. What's the result when you raise something to the integer 0? What do you get? Well, I heard it. Somebody said it over there. Huh? Did you say 1? Yep. So you get 1. So anytime you raise a base to 0, you always get a 1. One other case you'll see a lot is if you have a base a and you raise it to a negative exponent. So we'll also use n. So a to the negative n. Anyone know what happens when you have a negative exponent? I heard it, right? Somebody answered you change it to a fraction, right? So what you do is you put a 1 on top of a fraction, and then in the denominator, you have that same a base, but then that becomes a positive exponent n. So I would say they're the two special cases that you're going to run into. Okay. Okay, so this is sort of how I like to teach this class. I kind of give some formulae, some explanations about what's going on, and this is, I hope, simple. You've definitely, hopefully, have seen this before. And then I'll give examples. Okay? And we'll just go ahead and try doing them. Okay, so what about something that looks like this? If I have a -4 in parentheses, and I raise it to the second power. So we don't have variables here, so we can actually evaluate. So anytime you have numbers in some expression, you can evaluate it to a final answer. So what's -4 squared? Yeah. It's a positive 16, right? So that's equal to 16. Okay? Now, this happens a lot, and I've seen it on exams throughout this semester because it happens all the time. What is the difference between what I just did and -4 squared without the parentheses? That looks like a 12 for some reason, but that's just, oh, it looks okay up there. -4 squared. Yeah. That one's going to be a -16. Okay? And I'm going to show you just why. You can separate that negative sign from that 4 like this. It would be -1 times 4 squared. Okay, you can think about it like that. Like that negative sign is really representing a -1. So if you do 4 squared, you'd get positive 16, but then you'd have to multiply it by -1. So that's why you're going to get a -16. We already have something about raising something to the 0. So every time you see a 0, it's 1. And then how about this one? We'll use the exponent rule, or the negative exponent rule. 2 to the -3. Right away, you know you're going to have to make a fraction. And then whatever you had before, you put the same base, but then the exponent becomes positive. So what's 2 cubed? That'd be 2 times 2 times 2, right? It's however many times you multiply it together. So what's 2 cubed? That's 8. So you got 1 over 8. Okay? All right, last example. If I have 16 there, how can I write that with an exponent? Yeah. Okay, I could do 4 squared. What if I wanted to, you're right, what if I wanted to keep the base 16? Yeah, if you have any integer, right, it's like in this case 16, that's the same as saying 16 to the first power. So anytime when you evaluate an expression, and because we're going to be doing some numerical addition, subtraction, multiplication sort of things with the exponents, if you end up ever getting a something to the first power, you can drop that first power, right? We just assume if you put 16 that you understand it's to the first power. All right, nice little review. Beautiful. All right, let's move on to the next thing. I forgot the actual stylus I like to use. So normally I would have a much bigger screen here, but I can't, well, let's just stick here. And then if I have to delete, I'll go back. All right, here's the next thing. Now, the next couple things are going to be some rules for dealing with exponents when you have multiple bases involved. So here we go. Here's another rule. Okay. And I'll use variables to start. Let's say you had a to the m power, and you want to multiply that by a to the n power. Before giving you an example, what would that result look like? The goal would be to end up having a single base a, right, without having these two terms, right? So what do you do to exponents when you're multiplying the same base together? you add them up, right? So this is really going to be A, sorry. See, as soon as I started doing it, I have to hit eraser on here and do that. So what you have to do is you have A to the m plus n exponent. Okay. So something simple, if we did A cubed times A, let's say A to the negative 1. Should I change that A to the negative 1 to 1 over A just yet? Or could I just go ahead and add the exponents? I could just go ahead and add them, right? So I add them together. Now, if you want, you don't have to really do these steps, but again, if you're going back to these notes, right, I'm adding, why is that doing that? Okay. That's really what I'm doing, right? I'm doing 3 plus negative 1, and I get A squared. So hopefully that won't be too difficult. Now, so that's example 1. Here's another one. Now we're going to start involving some numbers, some integers, with some of these variables. How about this one? 3x squared times x to the 5th. What do you do with the 3 there? By the way, when you just have something like x to the 5th, does that have what we call them coefficients. These would be the numbers that are next to variables like x to the 5th. The coefficient for the x squared term is 3. What's the coefficient of the x to the 5th term? It's 1, right? So you can think about this as 3x to the x squared times 1x to the 5th. So you just multiply the coefficients together if the bases of the variables are the same. So the bases are x. So that's like doing 3 times 1, which is just 3. And then x squared times x to the 5th. You just add those exponents. So you get x to the 2 plus 5. So my final answer is going to be 3x to the 7th. Okay. I'll try to remember to separate examples with these dotted lines so you know that they're not the same. I'll give you one more example here. How about this one's not too difficult, right? So in this case, there are 2 coefficients. You just multiply them together. So 5 times 2, you'll get 10. And then the y bases are the same. And then I'm just adding 3 and 4, and I get 7. So these will become second nature, and you're probably already used to these anyway. All right? All right. Any questions about multiplying bases with different exponents? Pretty solid on that? We're okay? Awesome. And if I'm going too fast, I'm actually trying to pace myself. But if you feel like I'm going too fast, if anyone's local to Northeastern PA, you know we talk really fast and it sort of all the sentences go together. And I grew up in Scranton, and I don't live in Scranton now, but I live close. So I tend to talk fast. So I'm trying my best to slow down a little bit. Okay, here's the next rule. So we did multiplication. The next thing would be division. So what if we had this situation? We had a to the m over a to the n. And I want to write that as a single base a. What do you do to those exponents when you're dividing? I thought I heard it. Yeah, you subtract. So this would be a to the m minus n. Okay. So just to show you how that works, let's take something like a to the 5th over a cubed. Now I'm going to write all this out using the first definition I gave you today. So a to the 5th is really just a times a times a times a times a. And then a cubed is a times a times a. So what could you do when you have a term in the numerator and the same term in the denominator? What could you do with those? Can't you cancel a pair of them out, right? So I could say, well, this a and this a are canceled. This one and this one, and then finally this one and this one. Now, does that mean I have 0 in the denominator? What's left in the denominator? There's a 1, all right? So the final answer here is just going to be whatever's in the numerator, because anything divided by 1 is the anything. So I have a times a, which is a squared. And when you look at the definition, if I did 5 minus 3, I would get 2. But that's why it's possible, okay? I mean, these are pretty straightforward. If you have x, here's another example. X to the 6th over x squared. Again, that's very simple, x to the 4th. But what you could have integers involved. So something like, let's think of a good one, 27y to the 4th all over, oh, this will be a good one, all over 9y to the 6th. Okay. So I'd like to simplify that using the rules we've come up with so far. So this is just my preference. I always like to deal with the numbers first, right? I'm dealing with the numbers. So I'm going to leave it in fraction form. So what could I do with the 27 and the 9? Yeah. Yeah, so what I'm going to do is I'm going to divide the 9 out here. And what really I'm doing with this 27 is I'm just changing it to a 9 times 3 and then canceling those 9s out. So all that's left in the numerator then is a 3. So I'll leave that there. And then how about the y's? What do we got? Now you might right away see that how many y's should be left on the bottom. If you have 4 on top, 6 on the bottom, there should be 2 left over, right? So if you could see that, that's great. All right, but you could do this. Or you might see it as 3y to the negative 2. But isn't 3y to the negative 2, aren't these equivalent? 3 over y squared or 3y to the negative 2. Now, one thing you'll find out later on in this section is when you're simplifying expressions, we do not like to leave negative exponents in the final answer. All right? So the more acceptable answer here would be right here. So try to avoid negative exponents in the final answer. All right? So far, so good? Awesome. All right, next rule. Let's say we have a base, A, and we are raising it to the m power. But then we want to take that whole expression, that a to the m, and then raise that whole expression to the n. So if I want to write this with just a single base, what do I do to the m and the n? Oh, I heard it. Multiply. So it's really m times n. So something like 5 squared raised to the 3rd power, right? 2 times 3 is 6, so then we have 5 to the 6th power. Pretty simple. I'm going to give you 2 more examples here just because sometimes these get tricky. Let's do 2y to the 3rd power raised to the 4th power. So these are examples. So what do I do here? So not only do I have that y cubed, but I also have that 2. Do I just bring the 2 out, or do I also have to raise that 2 to the 4th power? You do. So you could do this in succession. So again, I like to start with the integers. So I'll just write over here 2 to the 4th, and then do the y base. So y, and then 3 times 4 would be 12, and I get 12. Now, you don't want to leave this as your final answer either, okay? Never leave an integer that's not a variable raised to a number. Just go ahead and evaluate it. So 2 to the 4th would be 2 times 2 times 2 times 2. So that should be 16. And during this class, you'll start to remember those even higher exponents. Just when you're doing these problems, it makes it easier. So your final answer is y to the 12th. Okay. And let's see. Anything else I want to give you as an example? Yeah, one more. How about negative 4x squared raised to the negative 5 power? So there's a couple negative signs here. Okay, if I did the same process I did before, so in the previous problem, I did the integer 2, raised it to the 4th power. I'm going to do the same thing with the 4, but how should I write it? Should I write it like negative 4 to the 5th? Or should I have parentheses around the 4? Which one? You want to have the parentheses. So because we'll just leave it there for a second, and then we'll do the x. So it's 2 times negative 5. Again, when you're doing these exponent multiplications, you got to keep the negative sign. So that's going to be 2 times negative 5 or negative 10. Okay, so let's start simplifying. Okay, I'm not sure why I picked 4 to the 5th. So 4 to the 5th is going to be 4 squared 16 times 4 is 32 times 4. It's 128 times 4 and 512. Is that right? See, this is where it's completely fine to bring out your calculator. So, and again, anytime I'm doing a calculation, feel free to check to make sure I'm doing it right, because I would hate to have notes on here that are incorrect. So 4 raised to the 5 power, well, it's negative 4, but it's going to be, okay, well, 1024. I was almost there. Now, what happens to that negative sign? And I'll just write this off to an aside here. Negative 4 to the 5th would be like this. Negative 4 times negative 4 times negative 4 times negative 4 times negative 4. So when you do negative 4 times negative 4, you get 16. And then another negative 4 times negative 4 is positive 16. But do you see how there's going to be a negative sign left over? Does everyone see that? So that means when you raise a negative integer to an odd exponent, the result is still going to be negative. So here's what I'm going to have in front here. It's going to be negative 1024. And then it's x to the negative 10. So what happens to that x to the negative 10? I got to get rid of it. Where does it go? That's a comma right there, by the way. Then the x to the negative 10 just becomes an x to the positive 10 in the denominator. Okay? So watch those negative signs. Okay. Beautiful. All right, one last rule in terms of how to work with these exponents. By the way, do you care if every once in a while I take a sip of my water? Is that okay? Like, is anyone, and if you have a problem with it, like at the end of class, just let me know. Just from talking so much, it just really, and with the mask, like, does anyone else feel like when they're talking a long time in their mask, I feel like you're sort of inhaling all the carbon dioxide that you're exhaling, and it does kind of take a toll on you at some point. So if you just need to walk out of the room or something and just breathe or something outside your mask, I mean, I feel like that's completely reasonable. All right, here's the last rule. If you have a fraction, a over b, and again, we're going to raise it to the n power. Do you raise both the denominator and the numerator by that exponent? You do. So this will just become a to the n over b to the n. Very simple. How about this one? A over b to the negative n. What does that do to the outcome? Wouldn't it just flip where the a and the b are in the solution to the previous example? This would just be, here, I'll write it all out. A to the negative n over b to the negative n. But what do you do to get rid of those negative exponents? You flip them. So the b to the n is going to be on the numerator, and the a to the n will be in the denominator. So I'll just give you one example here. If you had, because these will all be the same. If you had, well, maybe I'll give you two. 1 over 4 raised to the negative 2. So let's distribute that negative 2. So it's 1 to the negative 2 over 4 to the negative 2. So what's 1 raised to any exponent? Isn't it just 1? So I could do 1 to the millionth exponent. I'm still going to get 1. So this top is 1. And then what happens to that 4 to the negative 2? Well, I'll write it out. 1 times 4 squared, right? Because I'm going to take that negative 2 exponent and flip that up to the numerator. And the final answer is going to be what? 16. Now, if you feel like ignoring this step of leaving that 1 out, feel free. That's fine. It's assumed I'll know that you understand that that 1 is going away, because we never really have a leading 1 in front of anything. All right, we'll just do one more of these with, actually, you know what? No, I'm going to wait, because I see an example down lower that will accomplish the same thing. I like to change colors mid-lecture too, just because I get bored of the color that's there. Okay, so here's the important, why was I showing you all this? Well, this is where we're going now. So simplifying expressions. Okay. Because we really haven't talked about equations yet. You see equal signs here. Well, all I'm saying is that whatever's on the left side is equivalent to the right side in terms of expressions. But we haven't had an equation, so we're only dealing with expressions. So there are 3 rules I'd like you to follow, and these are in the book too, but I think it's nice to talk about them. So when you're giving a final answer after you do some type of numeric multiplication, division, addition, subtraction, what you want to see is each base appears only once. And this includes integers. So if you have, let's say, 2 variables in your expression, let's say x and y, at the end, I only want to see x and y one time. And then if there's a number involved, there's only one number. Okay? Unless it's a fraction that can't be simplified, then that's completely fine. All right, each base appears only once. All right, each exponent is a positive number. So that just means get rid of those negative exponents. And then the last thing would be no power. Well, I should use the same term here. No exponent. By the way, if you hear me say power, exponent, they're equivalent. No power is raised. No exponent is raised to another exponent. So in those examples I just gave, right, where were they? Yeah, any of these where I have multiple, yeah, right here in the here, like x squared raised to the negative fifth. You don't want to leave a final answer looking like that. All right, you're always going to want to have them not to have exponents raised to exponents. Okay, so let's try some examples here. This will kind of also wrap up all the things we've just did. All right, so here's some examples. All right, so let's do this. Let's multiply two expressions. All right, so we have two variable bases, x and y. And then we have some coefficients out in the front. So I always like to deal with the coefficients first. So we have negative 2 times 5, that's negative 10. And how about x? What's my x term going to be? Yep, 5, because we're adding the exponents because we're multiplying. And then how about for y? Right, you just, again, we're multiplying, so we're adding, so 2 plus 5, so we're going to get 7. So this would be my final answer. And when we have quizzes and exams, I will ask you to box your final answer. That way, when I'm grading, my eye catches the boxed answer, and I can immediately check to see if that's correct. And if it's not correct, I'll go back through your work to try to figure out the part of the problem where you made a mistake. All right, how about this one? This is a pretty good one. I'm going to give you a fraction. X to the fourth over 3y to the negative 2 power. Now what I'm going to do here is I'm going to raise that entire fraction to the negative third exponent, or negative third power. All right, so if you saw that, what would be the first thing you'd probably want to do? And then I'll tell you what I would do. What's the first thing? I personally see two things you could possibly do. You could either take that y to the negative 2 power, flip that up to the top, right? You could do that first. Or you could do that negative 3 exponent first. I like to do the negative 3 exponent first and then go from there. So here's my next step. So what's going to be in the numerator with that x term? Yep. We're going to have a negative 12. Negative 12. All right, then you just do the same thing for the numerator. So we're going to have 3 to the negative 3 power, right? And then what's the y term going to be? Well, it's going to be negative 2 times negative 3, which is a positive 6. Okay. All right, now I'm going to flip the terms that have negative exponents. So that would mean the x to the negative 12 is going to go down into the denominator, right? Because anytime you have a negative exponent, or wherever you are in the fraction, you got to go to the other side. So it's going to be x to the 12th. The y to the 6th doesn't change at all. And then we have 3 to the positive 3 in the numerator. That's supposed to be a 3. And then the last thing to do would be to evaluate that. So 3 cubed, 3 times 3 is 9, and then 9 times 3 is 27. So my final answer here is 27 over x to the 12th, y to the 6th. So that meets all the criteria that I gave out, right? Each base appears only once, that's true. Each exponent is a positive number, also true. And then no exponent is raised to another exponent. So we've met the criteria there. Okay, beautiful. All right. So we are on to the last little bit of section P2. And this would be scientific notation. Now, in the science community, and probably, well, most definitely, let's say like economics, business community, like let's say your business is really good, okay? Let's use, I guess, Facebook as an example. Does anyone know like the net worth of Facebook? I don't, but do you think it's probably in the billions? Yeah, billions. So, how many zeros are in billions? Right, there's like millions would be 6, so it's like this. Right, so and like these zeros could also be different numbers. You're not going to want to write out numbers like that, okay? So scientific notation gives us a way. I want to see if one of these buttons allows me to erase. Oh, yeah, it is. Oh, sweet. Okay, so when you want to represent really large numbers or really small numbers, what's a really small number? How about this? Just because I'm in physics, the weight of an electron. I should say the mass of an electron. Anyone know it off the top of their head? Mass of electron? Okay, I'm going to do it. I'm going to try to write it all out here. It's let's see, 1, 2, 3, 4, 5, 6. Kilograms. So do you think scientists want to write that out every time they want to talk about the mass of an electron? They don't. So for really small numbers and really big numbers. Okay. All right, so let me just draw out that like what a scientific notation looks like. So I'll use a variable for now. So you're going to have some coefficient, C, and you're going to multiply that by a base 10 raised to an exponent n. All right, so C, what could C be? So this is a real number. Okay, now can real numbers be decimals? Is that possible? Right, because integers can't be decimals, right? Integers are just 1, 2, 3, 4, 5, and then also the negative integers. But a real number can have the decimals. So C is a real number, and I'm saying in decimal notation. So you never want to see C written as a fraction. And decimal notation just means there's decimals. Okay. Now, the important part here is that C has to be at lowest 1. Are you familiar with this kind of notation using greater than and greater than, less than, greater than? So C has to be greater or equal to 1, but it also has to be less than 10. This is like the tidy way, or I would say the correct way to do this. Sometimes you will see C's that are greater than 10, but generally speaking, we want to have a number greater than 1 but less than 10. Greater than equal to 1 and less than 10. And then, of course, in this formula here, n is an integer. All right, so here's some examples. Okay. Let's go ahead and do that 9 billion number I did. So 9 billion was that many. Okay. Okay, so we want to rewrite this. Now, it's important that you understand where that decimal point is. So, if you start from the decimal point and go to the right, so we're going to be moving this way because we eventually want to get over to this 9. I mean, you don't have to do this all the time, but in the notes I want to have them there. So we moved 3 decimal points to get there, 3 more to get here, and then 3 more to get to the 9, okay? So that means when I'm writing my scientific notation, I'm at the 9, and then I'm multiplying by 10 to the. Now, how do you know what the n exponent is? It's how many times you moved the decimal point. And if you're moving it to the left, your integer will be positive for your exponent. So that'll be 9 times 10 to the 9. Now that's much tidier looking, right, than having to write out 9 billion. All right, I'll give you the example for the electron. Now I'm not going to write them all out. So essentially it's 0, 0, 0, and I'm just going to put some dots here, and we end up at 0, 9, 1, 1. Okay. Now notice when I was doing the large number, the 9 billion, I was going to the left. So if I want to do scientific notation for a small number, you're going to see, aren't I moving to the right? Right? So I'm moving to the right. So if you're moving to the right, the exponent's going to be negative. All right, so you would eventually get to this point here where you would have 9.11, and it's times 10, and it's actually to the negative 31 because I'm not actually counting them all out. So you're going to see you're not going to want to write out 9.11 times 10 to the negative 31. So that's 31 decimal places. You're not going to want to write that out. So scientists, and not just scientists, economists, people who are starting businesses, because hopefully your business succeeds and you're going to be dealing in these big numbers. So you're going to want to make sure you can do that. So these are simple. So I'll just give you one more example just of something simpler, like 0.00235. Okay. Again, I'm moving to the right 1, 2, 3. So this will be 2.35 times 10 to the negative 3. Okay. All right. Beautiful. Excellent. So, what I'm going to do is I'm going to give you your first homework assignment because we've completed the topics in P2. And I think I covered all the topics, but some sections that I cover, I won't cover everything. I'm only covering the things that I know are important to you. So if I'm in section P2, I have them written here. So this is homework. Okay. If by chance somebody doesn't have the book yet, before the end of class, if you'd like to take a picture of the problems page, I'm completely fine with that, okay? Just as I know, I've been hearing some stories about how the books have been arriving late. So if that's the case, just come up at the end of class and take a picture. So here's the homework, and they're all going to be odd. So it's on page, am I in the right page? Oh, that's P1. It's page 28. Page 28. And I just want to check to make sure these are still good. Let's see. Perfect. So you're going to do 23 to 43. And then, yep, 57 to 79. And these are quick. These are just like do an expression, simplify. So they're fast. And then finally, 87 to 93. Now these are all, I'm asking you to do only the odd ones. Only the odds. So realistically, what are you looking at here? There's 10, about 11, 21. So there's 23 problems. It's nothing significant, okay? It's your first one. But that is section P2. Okay, so here's what we're going to do for homework. Again, I'm going to try to limit the amount of paper that we're exchanging, right? Because COVID is supposedly lives on surfaces for a certain amount of time. So what I'll do is if I do collect a homework, and if you remember from the syllabus, if you hand in the homework and it's satisfactory, it's +2 points on your next exam. If I deem it unsatisfactory, you don't hand it in at all, it's -2. And, you know, you can get -2, -1, 0, +1, or +2. There'll be a spectrum of how well you do. I'm going to actually have you hand that in electronically. So here's what I'm going to do. I'm going to start the next section, but I would quickly like to show you how I want to do this. Except I'm going to need my keyboard. Does anyone have a Microsoft Surface? No? It's the best laptop I've ever had. It's amazing. Love it. I once accidentally typed the password in the username field, and then I had to go change it, because once you get in here, you could basically do anything. Oh, by the way, did you do your You Can Come to Campus thing today? I know a lot of people are going to forget just because it's new, but really try to do that as much as you can, because that'll also help with contact tracing. All right, so I'm going to go to D2L, and I didn't get a chance to show you this last time anyway, so this is good. So I'm only teaching 2 classes, an online Earth Science course and then this Math 106. So when you see this crazy red-blue lines, that was the one that popped up when I first went on here, and I'm like, oh, that's kind of cool, so I just kept it there. So right now I only have my welcome there. But what I will do is in the Dropbox area, I don't have any yet because there's not a homework to collect. But what I'll do is I'll make a Dropbox folder here. Has anyone ever did a Dropbox before? Or is this new? No, haven't done it? All right, let me just show you real quick. So let's make a folder. And maybe, I'm going to collect this homework assignment next week. So this is the one I'm going to tell you ahead of time, but normally I don't. So we're going to call this homework number 1. And I don't have to do anything. I do want to point one thing out here. It says unlimited. So if you accidentally submit something, you're like, crap, that was the wrong thing, or it wasn't the one that was complete, just submit another one and I'll grade the most recent submission. So I hit save and close. And here it is. So how it'll work is if I view student, can I do that here? So you'll go to Dropbox. So it'll just be sitting here. You click it. And then you literally just hit add file. And then go to wherever the homework is. Now, how do I want you to hand this in? So I'm going to say this with the hopes that, most of you comply with this. I would like you to submit one thing, right? I've had people in the past submit like eight images. And then I have to go through each image to see if you did well. The thing I do when I want to take pictures and then put it into a document is I take the pictures, I email them myself, I open up Microsoft Word, paste those images in, and then just save that Word document as a PDF. If you have an iPhone, I don't know where it is, to be honest. Oh, here it is. If you have an iPhone, there's a way you can use the Notes app to actually scan in your documents and it makes it a PDF. So however you have to do it, I would really appreciate it when you hand in your homework to just make it one document. So here's the thing. Since it's the first time and I want you to have a couple days to figure out to make sure you could do it, I will be collecting that homework assignment. And again, it's only for your benefit because it's only going to help you on the exam. So I'll set this will be set up. I'll make sure everything is good. And feel free to submit that, but I want it submitted prior to class. All right, so the next class is Tuesday. Submit it by Tuesday. All right. I also have a video about how to make one of these documents from a previous class, so I could also link that video as well. So if you want to see how I do it, this is probably the old. You know, I'm getting old. I'm getting up there. I'm not quite 40, but I'm approaching. So I'm doing things differently than you guys. I like to take the picture method, paste it into Word, save it as a PDF, and then it's all right there. So I'll post that video today as well, so you can see how I do it. If you like that way, do it that way. If you have a different way of doing it, that's also fine. Okay? And this will limit the amount of paper exchange. The only thing else I wanted to show you here is in the Content tab, you can find our syllabus. And again, if you haven't gone through the syllabus, please do so. I'm going to be getting rid of this notes area because I'm going to be sharing that notebook with you through your email, so you can access that notebook at any time. We tested it out today and it worked good. But what I'm going to, can I change this, I wonder? Oh, I can up here, I think. Did I change that? No. I'll have to, well, I'll just leave it there. Because I'm viewing a student. Go back to content. And change title. I'm going to call this class videos. So when you go here, all I'll have here are YouTube links, and those YouTube videos of the class will just pop up here. So if you are sick or something and you're not sure if it's COVID or you're just not feeling well, you'll be able to view that video, okay, at your leisure. And then just make sure you view the video prior to the previous class. So that should be up at some point today. Okay, so that's what's going on with that. So let's go back here. And when you actually go here, so you'll see that there's a tab here that says Section P.2. I'm going to change to the next tab and do Section P.3. Okay. And you'll see I'll just have notes by section. All right, wonderful. This is good because if you've noticed, I finished this section at the exact same time we would have been finished in a 50-minute course. So it's that because the last time I taught it was like that. So that worked out well. And now P3 is a little thicker, so I won't not get to the end of it, but I figured let's start it and see where we get. And again, this could be a review, but not necessarily. It could be new to some people, or you haven't had it in so long that you don't remember. All right, so this is Section P3. And it's on polynomials. Polynomials. So we've been dealing with polynomials in this previous section. If you have a single term, right, any of the ones we just did in Section P2, let's find a good example here. Yeah, so like -10, x to the 5th, y to the 7th. That is a polynomial of a special type, okay? And they're called monomials. All right, when you only have one term of the polynomial. So just so I don't have to write polynomials all the time, I'm just going to write poly of one term. Yeah, so here, as an example, something like 5x squared. All right. Now 5x squared looks like this. Because in math, we always try to give an example and then show you how it looks like a typical example for a monomial. So this looks like a coefficient a, and then some variable, in this case x, raised to some exponent k. All right, so a, this is a real number. So you don't always have to have coefficients that are integers. You could have them as real numbers. Now k, we already know what that is. That's the exponent. This is the degree of the polynomial. So in my example of 5x squared, that would be degree 2. All right. Now, certain degrees have names. Does anyone know what's the name of a degree 2 polynomial? Anyone know? A degree 2 polynomial has a name. Anyone? We're good? Nothing? Take a stab? Nope. You'll know as soon as I say it. Have you heard of the term quadratic before? Yeah, right. So a degree 2 polynomial is a quadratic. Okay, so how do we make, what do we do with these monomials? So 2 monomials, and I'll call them 2 monos. 2 monos of the same degree can be combined. Okay. So over here, I'm going to put a big X through here because I'm going to give you the counter example to this. If I have something like 2y squared plus 3y to the 5th, can I do anything with that? I can't, because the degree of each monomial, so really it's the numbers, the exponents of the y terms do not match, means you cannot combine those. Okay? But something like this, 3x squared plus 5x squared, you can combine those. So when the degrees are the same, your final answer is going to have that exact same variable raised to that same exponent. And then you just add the coefficients. So that would be 8x squared. And by the way, when you have two monomials in the same expression, that has another name. That's called a binomial. And think about it. Mono means 1, bi means 2, poly means many. Okay. All right. So far, so good? Yeah? Awesome. All right. We'll talk about polynomials of one variable, and that'll take us to when we have to start wiping down the desks. So polynomials of one variable. All right, you're going to see polynomials of one variable throughout this course. So let me just give you a definition here. So I'll say poly. We'll say in the variable x is a sum of monomials in x. All right, so if we're looking at a polynomial of one variable, each monomial all better have just the single variable x. So I'm going to give you just an example. The book has a really long equation that gives you the general look of any polynomial. I don't know that that's super necessary, but here's an example. Something like 6x squared plus 2x plus 1. All right, that's a polynomial. It's a quadratic polynomial, right? Because the highest degree is 2, but it also has all the other degrees, right? So you have 6x squared plus 2x. Now really, we never just leave the 1 as an exponent, but 2x is really 2x to the first power. And then how about this 1 at the end here? Is there an x term there? Doesn't look like it, but there is one hiding there. Are you okay with, I must have bumped something. Oh, yep. One of my programming things is opening. Okay. Oh, and of course it's blocking my, all right. Just have that last coefficient in the polynomial. Could it be written like this? 1x to the 0. Right? Because x to the 0 is just 1. So when you have a polynomial, you really have every possible exponent up to the maximum exponent in your polynomial. So they're all there. We just never write it like that bottom one because there's just too much going on. It's much easier to write it like the one above. Okay, how about this one? Okay, now, just want to see where we're going with this. In this one, there's some negative signs. We're eventually going to be using polynomials to solve equations. And we need to pick out coefficients from the polynomials. So in this first one, let's pick out the coefficients. So these will be the coefficients next to each of the x variables. And we label these coefficients A, B, and C. So there's an A coefficient, a B coefficient, and a C coefficient. So the A coefficient is the one next to the squared term. So that's 6. Just the x term, that would be 2, and then the c term is a positive 1. So they're easy when everything's positive to pick those out. Now in this example, I'm going to rewrite the polynomial a little bit. I'm going to rewrite it as 5x squared. I don't need to do anything there. And then I'm going to do plus negative 5. Is that how I wanted to do it? Yep, negative 5x, and then plus negative 6. So my coefficients here would be 5, B would be negative 5, and then C is negative 6. Okay, because I've seen it before. People would write them out as 5, 5, and 6 and ignore those negative signs. So if you need to rewrite it with positive signs, then you'll clearly see the coefficients are negative. Okay. All right, I'm just going to do one more thing and then we'll call it a day. So just like you could add, multiply expressions, a polynomial is just another type of expression. So we're going to be adding, oh, that's too many D's in adding. Adding polys. So I'll give you an example. Let me give you 2 long polynomials. So here they are. So you want to add those together using all the rules that we've talked about so far. So some of you've probably done this before. You could probably easily pick out what you have to do. But the book gives a nice way of doing it. So let me show you. So what they do is they put the first polynomial. No, I'm writing it a lot, but it'll be like that for a while. Now, do you notice in this first polynomial, you have 3x to the fourth minus 5x cubed minus x squared plus 1. Do you see that we're missing the x term? Right? So this is what they suggest to do. Put something that looks like this, 0x. Because that doesn't change the polynomial. It's just putting a placeholder for that x term. So plus 0x plus 1. So do you see how I changed that first polynomial to add in that x term? And then we're going to do the same thing for the second polynomial, except this time we're going to line up all of the exponents on the base variable x. So we have 5x to the fourth. Oh, I forgot a term too. Or no, this is a typo. Sorry. This should be cubed. Sorry if that was confusing. We have a cubed in this other one. What are we missing in that second polynomial? The x squared term. So I'm going to do plus 0x squared. And then we have a plus 2x term and a plus 5. Now, if you line it up this way, all you do is add vertically. So 3x to the fourth plus 5x to the fourth is 8x to the fourth. And then negative 5 plus 2 is negative 3x cubed. And then this one, the negative x squared just comes down because we have that 0. And then plus 2x comes down because we have the 0x in the first term. And then finally plus 6. So there's our answer. Now, of course, if you could just do it yourself, that's fine. The only thing I'll say is, if this were a question on an exam and you just gave me an answer, I would have no way of knowing where you went wrong. But if you did it this way, you're showing me work, and then I can give you partial credit. So however you want to do it is fine. I just suggest giving me more work on exams would be the best thing. Okay? Okay, so before you go, you have your homework. Don't worry about this section yet. I'll finish it on Tuesday, hopefully. And I will share with everyone this notebook and make sure you can access it. It'll come through your email. If you have trouble accessing the notebook, let me know, and I'll see if I could rectify that. Okay? So if you remember, when we leave, we're going to start with the first 2 rows. You come down, you grab a sanitizing wipe down whatever you touched at your chair. Once they're done and they leave, the next rows come down, and we'll just try to get into it because I'm obviously stopping 5 minutes early to do this. So we'll just do our best, and I want to make sure you get to your next class if you have one. And there you go. Oh, and I'm going to stop screen recording right now.